I don't know, x squared plus e to the x for x less than or equal to 0, and 2x plus, let's say, e to negative x for x greater than 0. And let's suppose I'm asked to find the integral from a negative 1 to 1, from f of x dx. All I want you to calculate and realize is that this is a function given as a piecewise. It's a piecewise different function given with two branches. So the integral from negative 1 to 0 will be from x squared plus e to the x dx, plus the integral from 0 to 1 will be from 2x plus e to negative x dx, and continue with the calculations. That's all. Basically, it's on the same page. This. We had problems like these on the homework. We did at least 2 in class, and this was another example. That's what I meant by properties. And of course, to remember that the integral from a to a from f of x dx, of course, is 0. That the integral from, we already used that, the integral from a to b from f of x dx is the same with negative the integral from b to a from f of x dx. These are very simple properties. But basically, that's what I had in mind. What is this property? What it says that the integral from a to b can be presented as the integral from a to c plus the integral from c to b. So a to b, a to c, c to b. In other words, we can break it up into 2 or more pieces. Good. So what is left? Yes?
Go over another example like that. I'm sorry.
You mean like these? We had them on homework. We had few in class. You can choose again. Feel free to choose. It's just the sum of 2 integrals. Yes, go ahead. Which one?
Number 3.
Okay, let's look at number 3. So g of x is the integral from negative x squared plus 5. I'm sorry, it's the function negative x squared plus 5 for x less than or equal to 0, or x plus 5 for x greater than 0. And the interval for this one is negative 2 to 3. So the property of the definite integral allows us to break up the integral as we please. So the integral from negative 2 to 3 from g of x dx. So negative 2 to 0 from negative x squared plus 5 dx, and plus the other one, which is the integral from 0 to 3 from x plus 5. Okay, so then we have negative x to the third over 3 plus 5x from negative 2 to 0, and then plus x squared over 2 plus 5x from 0 to 3. When I plug in 0, I get nothing, so minus. When I plug in negative 2, I have 8/3 minus 10, plus when I plug in 3, I get 9/2 plus 15, minus when I plug in 0, I get 0. So negative 8/3 plus 10 plus 9/2 plus 15. So I have 25 minus 8/3 plus 9/2. The least common denominator is 6. So a 6, a 2, and a 3. Okay. Minus 16 and plus 27. Okay, so 27 minus 16 is 11, so 161 over 6. I think we did the same problem in class, I think. The number rings a bell. Okay. Consumer surplus, producer surplus, differential equations, evaluating a function, domain of a function, and the d-test. Anything else? Okay, let's look at evaluate and domain. So let's say I have a function of x comma y comma z. Let's say is x squared plus y squared plus x, y, z. I just made it up. And let's say we're asked to evaluate for 1, 0, 2. Okay, so I plug in 1, I get 1. I plug in 0, I get 0. I plug in 1, 0, and 2, and this is it. Let's say I have a function of x comma y. That is, let's say the square root of x plus y minus 1 over x plus 2y. And I'm asked to find the domain. I know that this does not exist unless x plus y is greater than or equal to 0. I know that this does not exist unless x plus 2y is not 0. I'm done. The domain consists of ordered pairs x comma y, and all of them have to fulfill the following conditions: that x plus y is greater than or equal to 0, and x plus 2y is never 0. And this is the domain. Nothing else. I don't need to write anything else. Okay. Anything else? We have consumer surplus, producer surplus, differential equations, and the d-test for max min for functions of 2 variables.
We go over some differential equations.
Yes, absolutely. And that's section 5.7. You can find the page number. 5.7, 535. So here we're only asked, is this a solution? Plug it in. But the actual solving starts here, 15 and above. Till 42. Anyone would like to choose?
Can we do 34?
Yes, of course. Let's take a look at 34. In 34, we have 3y squared dy over dx equals 8x. Perfect. Okay. So we have to separate the variables. In order to separate the variables, 3 and y squared and dy can stay, but dx cannot. So we will multiply both sides by dx. So 3y squared dy equals 8x dx. That's pretty nice. Y alone on one side, X alone on the other. So all I have to do now is integrate both sides and use only one constant. Yes, you can say, well, I need a constant here and a constant here. Yes, true. Imagine that we move this constant here and we combine the two and we have only one constant. Okay, so then the left-hand side is nice and easy. It's 3y to the third over 3 equals 8x squared over 2 plus a constant c. These are gone. Y to the third equals 4x squared plus a constant c. All we have to do is apply the inverse function. And I got y equals the cube root. The cube root does not have plus or minus. 4x squared plus a constant c. The square root, plus or minus. The cube root, not. Okay, let's see if we want another.
Can we do 29?
Of course. Let's look at 29. 29. Okay, I see it. 29 dt divided by dt. Okay. 0.015 uppercase t. And they're giving us the initial condition. T equals 50 when lower t is 1. Okay. Okay, like before, we have to separate the variables. So I have to multiply by dt first. This is okay, but this is not okay here. And it's multiplied. So my only chance is to divide. So dt over t equals 0.015 lowercase dt. Okay, good. So now I'm ready to integrate. This is ugly because, not ugly, but more work. I have to write this. So natural log of the absolute value of t. And on the other side, that's nice. I have 0.15 t plus a constant c. I can determine the constant now or later, it doesn't matter. I know that when little t is 1, the upper t is 50. So then natural log of 50, that 50 does not need the absolute value, equals 0.015 plus the constant c. So c equals this minus this. Natural log 50 minus 0.015. So and now we are ready to solve for t. We haven't solved for t yet. We only determine the constant. So then t in absolute value equals e raised to this. So e raised to 0.015 t plus natural log 50 minus 0.015. And then t equals plus or minus. And now remember what we did several times in the past. E to a plus b plus c is e to a times e to b times e to negative 0.015. Now remember, the plus or minus is a problem here because only this will tell me which of the plus or minus to use. This condition is given to us. And I cannot use plus or minus because this is not going to be true for both. So when t is 1, when lower t is 1, upper t is 50. So I cannot use the negative because this is positive, this is positive, this is positive. So I cannot have the negative. This will not work. So then I will have to say only positive. So t equals e to 0.015t. This, we talked about this property. A raised to log base a of x is x, as long as this and the base here are the same, and they are. So this number is 50. And this is e to negative whatever. So e to negative 0.015. So let me rewrite a nicer format. So 50 e to negative 0.015 times e to positive 0.015 t. If you want to condense it, you can put the negative here and not write this separate. So here's another option. E to 0.015 t minus 0.015. Good, it was a good pick. Good. Consumer surplus, producer surplus, and the d-test. Okay, I'm going to choose a problem with the d-test. Or you choose, 576. Anyone? Oh, anyone would like to choose a problem with the d-test?
Can we do number 10?
Perfect. Let's do number 10. Okay, number 10. F of x comma y equals x squared plus y squared plus 8x minus 10y. Perfect. Very good. So remember, when it comes to the max min, we have to find all those partial derivatives. So fx is 2x plus 8. Fy is 2y minus 10. And then eventually 2x plus 8 equals 0, 2y minus 10 equals 0. And I have to solve this. So x equals negative 4 and y equals 5. I'm pretty sure we did this, but that's okay. So this is the point. But now I need to determine the other partial derivatives. Okay. So fxx is 2. Fyy, also 2. Fxy, 0. So then, the d for negative 4 comma 5 is fxx 2 times y times fyy 2 minus this squared. So this is 4. It's a number greater than 0. Also, fxx is also positive. When both are positive, this point gives a relative min. But what is the actual relative min? I don't know. I have to find it. I have to plug in the function this point. So I have 4 squared, 16 plus 25 minus 32, and then minus 50. So what am I getting? So this is negative 16 and this is negative 25. So I'm getting negative 41. So the D test, the D number was positive. The fxx is positive. When they're both positive, the negative 4,5 gives a minimum. And what is the actual minimum? I have to plug it in. I have to plug it in the function to find it. Okay, the last topic, consumer surplus, producer surplus. Are we okay with that one? We may be able to finish it in 5 minutes or not, but at least let's start it. So we have touched upon everything. And those are in 5.1. And 5.1 is on page 480. Okay, so we have a demand and supply, and we want to determine the consumer surplus at the equilibrium point and the producer surplus at the equilibrium point. So let's choose. Anyone would like to choose?
We do 11.
Okay, let's do 11. 11. Okay, so d of x equals 1800 over the square root of x plus 1, and s of x equals to the square root of x plus 1, x greater than 0. Good. Okay, so first we have to find the equilibrium point, and we have to set these equal to each other. 1800 over the square root of x plus 1 equals 2 the square root of x plus 1. We have to cross multiply. And we get 1800 equals 2 times x plus 1. We definitely simplify by 2. So I have 900 equals x plus 1, and I subtract 1. So x equals 899. So I got x, but that's not enough because I need the full point. So the equilibrium point is 899, and 899 plus 1 is 900. The square root of 900 is 30. 30 times 2 is 60. Then, the consumer surplus is the integral from 0 to 899 from the demand function minus this product. Lazy people, 899 times 60. So minus 53940. Good. And I have to calculate that. And the producer surplus is this, 53,940 minus the integral from 0 to 899, but from the supply function to the square root of x plus 1 dx. And we have to calculate these two integrals. Any questions? Any questions? So what I recommend here, use u as x plus 1 and du equals dx. So I'll finish one of them and we'll finish the other next time. So 53940 minus the integral. Do not copy the limits of integration. So u to 1/2 du. So when x is 0, u is 1. When x is 899, 900. So 53940 minus 2, u to 3/2 over 3/2 from 1 to 900. 53940 minus 4/3. When I plug in 900, I have 30 raised to the 3rd power, and then minus 1. Okay. So what is this? 3 to the third is 27. 27 and 3 zeros. Minus 1. Okay. So at this point, I will put in the graphing calculator to see what this is, because we have to approximate it. For consumer surplus and producer surplus, once we have this stage, we have to approximate it. So 53940 minus 4/3 times that in parentheses. What is this? 26999. So I'm getting 17941.33. So always go back and double check the answers. So 17941.33. So next time on Tuesday, that's the only leftover from tonight, we're going to calculate the consumer surplus. I just continue with producer surplus because it was right there.